Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 2. This is Section 11.2, Problem number 2. It says, consider the function f of x equals 2x plus 5 when x is greater than or equal to 3, and the function equals x squared plus 2 when x is less than 3. So you have two branches. When your input is 3 or bigger, this is how you calculate the output. And when your input is less than 3, this is how you calculate the output. So it has two parts. Is the function continuous when x is 3? And is the function continuous when x is 5? So first, when x is 3, we're going to answer the three questions that we have to answer to determine if any function is continuous at any point you want. Does f of 3 exist? So can I use 3 as an input and find an output? And the answer is yes. So the top branch of the function says if my input is 3 or more, my output is calculated by 2 times the input plus 5. So does f of 3 exist? Yes, it's going to be 2 times x, which is 2 times 3 plus 5. 6 plus 5. The output's 11. If I put in a 3, I can find an output of 11. So f of 3 does exist. So I get a yes for question 1. Question 2, does the limit of the function exist as the input approaches 3? Let me add that. As the input approaches 3. So since this function is split at 3, I really have to test both branches. So for input values slightly less than 3, 2.9, 2.999, I have to use the bottom branch. And for input values slightly bigger than 3, 3.1, 3.01, 3.001, I have to use the top branch. Again, the limit is not what's happening when I input the actual value of 3, but what happens when I input values super close to it. So the top branch, as we can see from question number 1, as I put in values close to 3, the output's going to get close to 11. The bottom branch, what happens when I put in values close to 3? So let me write it right over here. I'm going to have x squared becomes 3 squared plus 2. 3 squared is 9, 9 and 2 more. Oh, they both equal 11. The output gets closer to 11 when I use values slightly bigger than 3, and close to 11 when I use values slightly less than 3. So does the limit exist? And the answer is yes. Limit equals 11. Now, does f of 3 equal the limit as x approaches 3? Yes, they both equal 11. So is this function continuous at x equals 3? Yes, it is. Because f of 3 exists, the limit as x approaches 3 exists, and the value of f and the value of the limit are the same. So yes, it's continuous at 3 for part A. Now part B, is our function f of x continuous when x equals 5? So since 5 is an input value that's larger than 3, I only consider the top branch of the function for part B. 5 is bigger than 3, so everything's going to happen at 2x plus 5. So can I actually put in a 5? Yes, it's going to become 2 times 5 plus 5. So does f of 5 exist? Yes, it's 2 times x, or 2 times 5 plus 5. 2 times 5 is 10, plus 5 more is 15. So yes, f of 5 exists. Does the limit as the input approaches 5 for this function exist? Yes, that's also going to be 15. And does the value of the function at 5 equal the value of the limit as the input approaches 5? That's also a yes. They're both 15. So this function is continuous when x equals 5. It's continuous when x equals 3, and also continuous when x equals 5.